convert these into some cash flow diagrams. This one's relatively simple. This is just $300,000 now, and then there's going to be this constant series of $1,500 per year. So to just replace this with the diagram, and I'm going to write these as if they are all costs. So there's our $300,000 cost in time period 0, going all the way out to year 20 over here. And there's a convention that when you're making initial investments, that's things that all happen in time period 0. And then when you have these additional costs, those things commonly start in time period 1. And so what we're going to have here is a long series of constant $15,000 a year costs, extending out to time period 20. Now this problem right here, because of the way it's stated, guides you on how to break it up into its parts. And you could turn both of these two sets of phone lines into a single cash flow diagram like that, but it's probably not the best way to solve the problem. The best way is to think about it as this is a line, literally a cash flow diagram line. This is also a line, literally another cash flow diagram line. And so to get these guys up on the board, we have the first year's installation costing $150,000. That's in period 0. And then what we have is our expense, $10,000 a year for all 20 years out here. And then what's going to happen is that in year 5, and we'll go ahead and draw on a line here that indicates year 5, you're going to have a second installation of $150K. And these are going to have an additional $10,000 maintenance expense associated with it. So these give us our two cash flow diagrams for our two options that are available to us. This is the all now option. This is the part now option that's right down here. So after we have come to some agreement on what these cash flows are supposed to look like, the thing we should do next is start writing out what these are supposed to look like in cash flow, factor notation. And so these can actually be something that's relatively simple. Switching over to green. For this one, the present worth of all now is just equal to this initial expense that we have here, this negative $300,000. And then we have these additional expenses here, and this is $15,000, and that's every single year for 20 years. So it's looking for P, you know A, whatever their interest rate is, we'll figure out what that is later, with an N is equal to 20. And that gives you the present worth of this option. This second option is slightly more complex because it has a few more parts to it. And so I'll scroll it in over here in this particular corner. So this is the present worth of the part now option. What we're going to have here is the present worth of this line's installation, which is $150,000. We'll put a negative sign in front of it. And here's that $10,000 per year for 20 years. So that's that first installation. This one over here is a little bit trickier because most of this stuff happens after year 5. So we're going to have some complicated time shifting there. And so I'll have a plus sign right there. Here's our big fraction. And what we have is our $150,000 installation. This is going to be in time period 5, so don't let that disturb you too much. Here's our maintenance expense. And this is only because this is time period 6 all the way out to 20. This is only for 15 years. And what we're going to have in the denominator is 1 plus the interest rate raised to the power of 5. And essentially what's going on here is that this top calculation, this already sits in time period 5, that installation cost. Then this term right here, that minus 10 times P to the P given that we know A, interest rate, and then 15, gathers all this stuff together that's in period 6 through 20 and dumps it all on time period 5. So we've got a lot of wealth that's concentrated right here. And what this term right here in the denominator does is it brings it all the way back to time period 0. And so now what we have here is the present worth of that asset.